Hi, this is Mick Elliott from Electronic Specifier, and I am on the Keysight Technologies stand with Pierre Teyssier, and we're here to talk about Keysight's 6G component analysis, which is being demonstrated at the show over its 3 days. Jean-Pierre, would you like to take us through some of the features?
Okay, so this setup is devoted to component testing at sub-terahertz frequencies. So it means we can go up to 250 or 300 gigahertz, and we want to test our new components like transistor, amplifiers, antennas. We need to test all these components at these frequencies to have building blocks of 6G communication links. So it's the early testing of components. I mean, we are not yet testing a full network. We are just trying to have good amplifiers, good antennas, good components, and we have a way to measure them here with wideband modulated signals. That's the key point.
Okay, now there's a number of Keysight solutions that make up this platform for testing vector network analyzers. Can you just talk us through some of the features of the instruments and what they bring to the solution?
So clearly this is still a classic network analyzer, so vector network analyzer approach. So you can, in a stimulus response, so you really know what you inject to the DUT and you get a response. But we bring this to 250 gigahertz and we still have very good measurement performances. And right now I'm demodulating a 64 QAM signal and I can still get an EVM below 2% at these frequencies and running at 20 gigasamples. So right now I'm measuring with a VNA a link that is running at 120 gigabit per second, and it's still working fine. So this is the noise floor of this instrument. So it means we can really add on top of that now, insert in this setup amplifiers, antenna, frequency converters, and see how good they perform. And so our customers will be really able to improve their components to build a network, to build the 6G network. So this is really the starting point to build the ecosystem of 6G.
Okay, but there's an arbitrary waveform generator in the solution, yeah?
Absolutely true. So here you have our 128 gigasample arbitrary wave generator. So this is our latest and strongest guy. So this guy can provide up to 50 gig of modulation bandwidth. So, and I'm running right now 40 gig of modulation bandwidth out of the PNA. And thanks to its extremely low phase noise, I can rebuild the waveform and demodulate the full waveform with less than 1 degree error across this 30 or 40 gig span at 250 gigahertz carrier. So that's amazing numbers, but clearly all this also scales down very well. I mean, right now I'm running at 250, but all the same setup run very well at D-band, at lower frequencies in the 90 gigahertz areas or whatever, and even without frequency extenders, just running the simple PNA up to the box capabilities, so 67 gig or 50 gig. So this scales down very well and with even better numbers, obviously, because here it's a pretty extreme one I'm showing, but this approach of doing wideband test signal in a network analyzer environment scales down very well to do all your component testing at under wideband stimulation.
What about frequency extenders? Is that a possibility?
So frequency standards, clearly now there's a big demand on D-band. There's a lot of work going on D-band for 6G. But also if we look the highest frequency we are looking at in 6G is really the 250 to 330, so the H band. So our setup is the most extreme one here with the H band. We are focusing, but clearly it means D-band, we have been running exactly the same setup with D-band in our lab, and it runs amazingly well. So we can cover all the new 6G bands with this approach. We just need to change the heads. Right now I have heads in a WR34 area with a WR34 connector. So it means it goes from 220 to 330 gigahertz. But if I go to another connector type, I will go down in frequency. So it's just a matter of changing the millimeter heads, the VDI heads.
Okay, and I guess this enables designers to start to get into testing their 6G components, and it helps them shorten the design cycle?
That's the idea. That's obviously you start, if you want to develop a PA for 6G, you start with S parameter, you want to see a gain. But very soon, right after, you need to see, okay, now how it handles a wideband signal, how it's nonlinear behavior, how it's memory effects. And this is all what we can do in a very easy way. Just insert the DUT and you go straight to numbers like EVN that give you an overall performance of a device. So it's a way to speed up the design of 6G components for sure.
Okay, and are you working with other companies to develop this solution?
So right now we are using VDI heads, so you see the PNA, but we can connect to the PNA different millimeter heads, and VDI has a new solution with a mixer that allows us to propagate this 40 GHz modulation bandwidth I can get out of my arbitrary waveform generator to the 250 gig carrier. So this is the new part. This part is the new part of VDI. This mixer that you can, I don't know if you can focus on that, but you can maybe see this block scheme here, where I have this part is my arbitrary generator and the mixer. So it's a way to feed the system with a wideband signal. But before that, we do a legacy S parameter. So this system has still the capability to do legacy S parameter with using the same calibration. Then we go to wideband signals. So you can start with your DUT in S parameter mode. Look at the gain, look at the frequency response, and then, okay, now it's time to apply a wideband modulated signal to this guy and see what's going on. Without disconnecting, keeping the same calibration.
Okay, and are there customers now using this solution?
So it's really a hot setup. I had a lot of people looking at it, but obviously it's a pretty big setup, and you need to have a kind of university funding from government or this like kind of thing. So because it's pretty advanced, you see, we are ahead of time. It's very early now to develop this solution. So our commitment is to be ready in advance, so our customers can begin to develop on time their components. So it's a pretty advanced setup, and but I think it's already pretty hot.
Okay, because you are working with universities and other companies, aren't you, in a collaboration to push this forward?
Absolutely true, and our first customer, we already is a university guy. There's one already running at a university, exactly the clone of this setup.
Okay, Jean-Pierre Teyssier, thank you very much.